Here's another final practice. The pieces of this problem contain different type of parameterization problem. So start with A. In A, it's asking us to basically put this function x equal to 6, this parametric form, into a Cartesian form. If I have sine and cosine, in general rule with parametric form is that you want to eliminate t between x and y and then have an equation containing x and y. Here the best way to eliminate is to solve for sine of t and then solve for cosine of t. So I get, in here I get 5 cosine of t is equal to y plus 7, or cosine of t equal to y plus 7 divided by 5. Then use the Pythagorean theorem, sine squared t plus cosine squared t equal to 1. So here sine squared is that to power 2. Here cosine squared is that to power 2. And that's your answer. Now for part B, the parametric form is x equal to 7t minus 6, y equal to t squared plus 4. To eliminate t between x and y, I see that one of these is linear, so I solve for that linear equation of t in that linear equation. So x plus 6 equal to 7t, so t is equal to x plus 6 divided by 7. Then I place t back in here, so it goes in there. Y is equal to x plus 6 divided by 7 to power 2 plus 4, which is actually a parabola. The first one was an oval. This one is a parabola. Now it's asking us the other way around. A Cartesian form is given, and it's asking us to find it in parametric form using trigonometric functions. What I do is, again, I use the Pythagorean identity over here, except that here two things that are two positive things added together, and I got 1, so I can assume the first one is, let's say, cosine squared t, and the second one is sine squared t. And so cosine squared t equal to x squared divided by 16. This solves to be x is equal to 4 cosine t. Sine squared t equal to y squared divided by 81 implies y is equal to 9 sine t. There is no need for plus and minus because cosine t and sine of t take the plus and minus in there. Now, the last piece is, again, you've seen this in other problems also, is to use this parametric form that you found and solve for this problem. It's the part C is we're asking to find the maximum area of a rectangle inscribed in the upper half of this oval. If you remember in GeoGebra, moving this x and y around over here, for example, make a smaller triangle over here, make a very thin, long triangle. The areas, when we start by the y-axis, put the x and y close to the y-axis, it's small, gets bigger, then again start smaller and smaller. So we want to find where in between is the maximum where we right before that it's getting bigger, after that it gets smaller. So first of all, I have to figure out what the area is. If this is x and this is y, this little area is x times y. So the entire area is 2x times y. That's the area. Now, if I use that, I'm going to get a is equal to 2 times 4 cosine t times 9 sine t. And that is going to be 36 times 2, 72 sine t cosine t. Here, the advice is to use the formula sine of the identity sine of 2t equal to 2 sine t cosine t. That means if I divide by 2 both sides, sine t and cosine t is just sine of 2t divided by 2. So a as a function of t is going to be 36 sine of 2t. So let's recap. We started with our objective function, and then we used this parameterization because this point had some constraint, and that was the parameterization. We used the parameterization here. I had 2 variables. We used that parameterization to convert that to 1 variable. Now I have a function of t only. And I couldn't figure out over here what the maximum is, because sine has a maximum at it's 1, cosine has a maximum that is 1, but they don't have maximum for the same value of t. Here, sine of 2t has a maximum at 1, and that's for basically they're not 2 functions, so you don't have to worry for the what value of t. And so maximum of this max sine is 1. Therefore, max a is equal to 36 times 1, which is 36. Now, what value makes sine of 2t equal to 1? And think about angles less than pi half. That gives you 2t equal to pi half, less than equal to, t less than pi half, and that is t equal to pi fourth. So putting it back in here, I get 4 square root of 2 over 2, y 9 square root of 2 over 2. I have 2 square root of 2 and 4.5 square root of 2. And so therefore here the dimensions are going to be 4 square root of 2, because 2 times x, there's another x here, times 4.5 square root of 2. But the question only asking, I did a little bit of extra. The question is just asking to find that 36.